In this video we're going to look at motion with uniform acceleration. The important thing is that it is uniform acceleration. These do not apply for when we have non-uniform acceleration. So when considering motion of objects with uniform acceleration, we need to consider the following variables. S stands for displacement, U stands for the initial velocity, V stands for the final velocity, A stands for the acceleration, and T stands for time. Consider the following velocity time graph. Consider the following velocity time graph. So we've got time along here and velocity in meters per second here. We've got an initial starting velocity here and we end up with a final velocity here. Uniform acceleration, so we've got a straight line. From this, the gradient of this line represents the acceleration, and so the gradient of this graph would be v minus u divided by t. Rearranging, this at will be equal to v minus u, and then we end up with v is equal to u plus a times t. What we're saying is the final velocity is equal to the initial velocity plus the acceleration times time. Considering the same graph, the area underneath the graph gives what's known as displacement. Now, one way to do it is to integrate this function here, v is equal to u plus at, with respect to time. So if we integrate, we get ut plus at squared over 2, and we're integrating between 0 and t. Putting in t, we'll just get s is equal to ut plus a half at squared, take away 0, which we're not even going to be able to write. So this is quite a familiar one. S is equal to ut plus a half at squared. Now, it's another way of finding the area. If you consider here that you have a trapezium, then the area of a trapezium is you add together the two parallel sides, divide by 2, and multiply by the height. So this is u, this length here is v, the height is going to be t, and then you divide by 2. So s will be equal to half of u plus vt. Substituting v is equal to v, the rearrangement of the first one, u is equal to v plus at into s is equal to a half of u plus v times t. You're going to have that s is equal to a half of v minus at plus v times t. So you're going to have s is equal to 2v divided by 2, which is vt. And here we're going to have a minus a half at squared. So it's very similar to this one, but it's a minus sign in between. And substituting in t is equal to v minus u over a into s is equal to a half of u plus v times t, that will give s is equal to a half of v u plus v, replacing u with v, replacing t with v minus u over a, and that will give you v squared minus u squared when you expand those two difference of 2 squared over 2a. And rearranging that, you have 2as is equal to v squared minus u squared, and this is one is normally written as v squared is equal to u squared plus 2as. So the completed list is given below, which are only valid, remember, they're only valid if the acceleration is uniform. So v is equal to u plus at. Some of these are worth remembering. S is equal to ut plus a half at squared. V squared is equal to u squared plus 2as. And these ones are not quite so familiar. S is equal to a half of u plus v times t. And s is equal to vt minus a half at squared. The last two are not used quite so often. Okay, and please remember they're only valid if the acceleration is uniform.